Welcome to the channel Professor Davinci. Strictly binary tree. Strictly binary tree is a type of a binary tree where each node has exactly two children or no children at the leaf level. Okay. Example, we can say example of a strictly binary tree. Suppose this is the tree of node A, B, C, D, E. So here we have the intermediate node has at least, at most, or at least, sorry, at least two children. So if we take A have two children B and C, and B have two children D and E, and the C is a leaf node, so it has a zero child. So this is the example for a strictly binary tree. For example, if I have a node like this, if I have a tree like this, A, B, C, D, E, F. So this is not a strictly binary tree. Why this is not a strictly binary tree? As per the definition, it has to have the intermediate. In short, we can say for every non-leaf node has non-empty left child and non-empty right child. That means the intermediate node must have at least two children. So here this is A, I can shade it. This A, B and D are the intermediate node. So they must have to have two children. For example, here in this case, say the A have the A have two children B and C, and B have two children D and E. So these A, B, C, D are intermediate node, but to C, D have only one child. So this fails our condition of a strictly binary tree. So this complete tree is not a binary tree, is not a strictly binary tree, right? Good. Now, so that meaning I can extend the definition. I can extend the definition of a strictly binary tree. It means that for every non-leaf node has non-empty left child and right child. So meaning this intermediate node must have non-leaf. So here which is the non-leaf in this one? Oh, this is the non-leaf, this is the non-leaf. For non-leaf node, for every non-leaf node have non-empty left and right child. So this non-empty have, this is the, for A this is the non-empty child and non-empty left and right child. For B and D is a non-empty, and this is the non-empty of a right child. If you see here, though D is an intermediate node, it has non-empty left child, good, but it does not have a non-empty right child. So this tree fails, this tree fails in a strictly binary tree. So this is not a strictly binary tree, and this one is the strictly binary tree. This is the strictly binary tree. Clear? Now, what is the properties? Some properties we can able to say. For example, n leaves for a n leaves strictly by I can say in short SBT strictly binary tree has 2n minus 1 nodes. Okay, for example, if you take this one here, in this case, n leaf, how many leaf we have? 1, 2, 3 leaf. Okay, 3 leaf. 2 into 3 minus 1, 2 3 are 6, 6 minus 1 5. So how many? 1, 2, 3, 4, 5 nodes. So if we have a number of leaves in a strictly binary tree, we can calculate the total number of nodes available in the binary tree. This is a very small tree, we can count 1, 2, 3. If we have a very large tree, it is difficult to count. So in this case, we need to use a formula, and in this one of the property, this one, n leaves contains 2n minus 1 node. For example, I can give one more example for this to realize this property. So this is A, B, C, D, E, F, G. Okay. For example, this is the strictly binary. Of course, this is strictly binary because all the intermediate node A, B, D have 2 children at least, right? They have. So how many leaves it has? 1, 2, 3, 4 leaves. So 4 leaves. How many total nodes? 2 into 4 minus 1, 2 4 so 2 into 4, 8 minus 1, 7, total 7. See here, 1, I can change the color. So this is 1, 2, 3, 4, 5, 6, 7. Yes, we have 4 leaf strictly binary tree has 7 nodes in total. Now, say I can say this is a first property. Okay, now I go for second property. Depth of, say, some node, depth of some node x, any depth equals length of the path 2x or from x. Okay, now I need to check the, suppose I take this one, this node D. Okay, what is the depth of this D? Is a path to D. So this is a 0 level, first level. I can remove this one. So I need to find the depth of D. For example, depth of D. See, depth of D. What is depth of D? Depth of D equals, this is a level 0, level 1, level 2, level 3. So D in the depth is the length 0, 1 and 2. So this is the depth is 2. Similarly, we can say the third, height of some node x equals, it is just opposite to depth. It says that depth from x to the leaf. What's the depth? Suppose if we take D, what's the depth of D? This is 0 level depth, first level depth, second level depth, third, just a vice versa. See here, this goes in depth goes in this way and the height goes in this way. So height is the depth of, what is the height of D now? The height is 1. Okay, depth is 2, height is 1. Clear? So this is the some properties of a strictly binary tree. Now let us compare with some other. We compare with the binary tree, strictly binary tree, and a complete binary tree. Now, what is binary tree? Binary tree has at most two children. Two children meaning it may have 0 children or 1 children or 2 children. For example, this is one example. So this node have one child, two children, or it may have like this. It may have like this. So only one condition, it must have 0 children, 1 children, or 2 children. So this is also a binary tree. But if I have, this is not the binary tree, 3 children. If a tree has this, so this one is not a binary tree. Okay, right? Now here strictly binary tree, only 0 or 2 children. So condition, what is the condition here? Condition, leaf node may have 0 children, 0 child, but intermediate, that means non-leaf node, must have at least 2 children. For example, already we have seen the example, this one. So this one is the 2 children. Intermediate, this is the intermediate node. Which one? So intermediate node have 2 children, but leaf node, this is the leaf node, they don't have the child. Then the third one, complete binary tree. Complete binary tree is all levels are filled, must be filled, or all levels are filled except the last level. So this is the first level, 0th level. I can have like this, or I can have like this, 0th level, first level, or I can have like this. Okay, so that means the level must be filled, but it should not have like this. It should not have, because here this first level right child is missing. So this one is not a complete binary tree. So complete binary means what? Except the last level, all the level must be complete. So if I draw a little bigger, like this. Okay, moreover, the last level we have to fill from left to right. You should not have like this. For example, this one is skipping this one, you should not have like this. That means here 2 are missing. Okay, you should not have like this, you should not have missing. You need to fill from left to right. So that means you have to fill here, it has to come like this. So if you want to have only one child, it has to come like this. Okay, so this is the complete binary tree. So now I hope you understood what is binary tree, what is strictly binary tree, and what is complete binary tree. Okay guys, see you, have a great day.